Hey, thanks everyone. I don't want to pre-warn you. Hopefully my voice is going to last through this. I last night found out I was running a low-grade fever. But I woke up this morning and I'm doing much better. Ibuprofen is a wonderful thing. I've often given this talk in a much longer talk slot. I have a shorter slot here today, so I am going to try to sort of push through stuff to give you the broadest overview that I can. If you have any questions, I'll be around the rest of the day. I'll be around this evening. Please come find me. I do have a couple sort of live security exploit examples. I'm going to go ahead and skip over those to make sure I make it all the way through the end by my time slot. If we have time, I'll go back and show a few of those off. It's also a small screen, so I'm not sure how well you'll be able to see them anyway. So let's go ahead and get started here. So the first question that often comes up whenever I'm talking to someone about security is I often hear the phrase, oh, web security, why do I need to worry about this? Is anyone really going to try to hack my little website? No one's going to try to do that. The main answer to that is, yeah, right. It doesn't matter how big or small of a website you have, someone will try to hack you. And the thing is, it only takes one person. And it's not even the case of, oh, well, no one knows about my website. I haven't even published it really yet. If it's on the internet, someone out there is running a script that's checking every single IP address one by one and using automated hacks to try to get into them all. You can put a new machine online and immediately start seeing hacks come in. So it is something you need to worry about, and it's something you need to worry about from the very beginning as you start to build your website. I do want to point out, before we start here, there is this great resource, OWASP.org, the Open Web Application Security Project. It is the best online resource for really learning about these various attack vectors that come in. It's the best place to find out about new attacks as they come out and how to defeat them. I will give you one big caveat of warning, though. It is a wiki user-edited style website. Take a lot of their solutions, especially their PHP solutions, with a grain of salt. Especially if you look at they have a page that's the PHP security quick start list kind of thing. And like, number one thing is, don't use PHP. I'm like, really? You're not being helpful here. And they have there's a whole bunch of stuff you'll read through there that, like, they're suggesting stuff like, to handle PHP session security, simply turn sessions off. I'm like, you're not helping. So it's a good resource. Just take the solutions with a grain of salt. Find out about the attack vectors via them, and then Google for solutions sometimes. So the first thing I want to talk about are things that aren't really direct security attacks, but are security holes caused by, unfortunately, stupid programmer errors. And I know every single one of these I have done myself at some point in the past, and they're things that shouldn't happen. They're things that if you're doing stuff correctly, none of this should ever be a problem. One of these is having unchecked permissions. So the idea is having direct URL access to a protected file. If you can't read this here, this is showing an example of, this happens to be a ping, a graphic file. There happens to be some classified document that, say perhaps through the use of your website, the only way someone's ever going to get to see this particular document is if they were a logged in user. And by being a logged in user, they now get a list of here's your private documents that you have access to, and there's URLs to them. But if those URLs are just direct URLs to a graphic file, that's not running through any of your PHP code. If someone happens to get access to that URL, anyone can see that file. All right? So you have to worry about this. If you have a media file that needs to be protected, that someone should not have access to, then you have two options. One is either use basic HTTP auth, where Apache or whatever your web server is itself is protecting the files, or never have a direct URL that can serve it up. Always have the request for the graphic go through a PHP script, and the PHP script itself read the file and return the file. That way, inside of PHP, you can be checking security and does this user have access to this file. The drawback of that is that to just serve a simple graphic file, you're now having to invoke PHP and have PHP read the file in and return it back through a stream IO. However, you're able to always have your permissions checked at every point. The next and similar related one is someone having the ability to URL hack, i.e. to edit the URL on the fly, to then gain access to unauthorized data. There was a very big case of this that came out and with a bank. I'm not going to say which bank it was. But there was a particular bank that it turned out that when you logged in, of course, it took you to your account's page, right? But people noticed that if they looked up, come on, there we go. If they looked up in the URL, their account number was part of the URL. And so someone on a whim went, what if I change that account number and hit enter? They were now viewing someone else's account. Because all that the code was doing was checking, is this a logged in user? Not, is this a logged in user and is this their account they're viewing? And unfortunately, that's a simple mistake to make because you're just, especially if you're quickly moving forward and you're going, okay, so I'm going to make sure they're a logged in user, and once they're logged in, I'm going to show them their page, and you forget to do that one extra step of, oh wait, are they viewing their own account? So you have to think about these things. Another one are information leaks, all right? If someone's going to try to start hacking you, this is not a security issue in and of itself, but it gives people ammunition. You don't want to give someone who's trying to hack you any ammunition to help them hack you, okay? The main issue with information leaks with PHP is having visible error handling turned on, all right? You should absolutely, in my opinion, have visible error handling on your dev machine. You should never have this turned on, never have display errors turned on your production machine. So again, so in this case, you now know the structure of my code base. You now know how some things are stored. You now even know what line number a certain thing was. You even know that, okay, so this exception happened to be a database get connection read, and who knows what else could come across in that. And any amount of information you give someone is something they can now use to try to attack with. So don't do that. Another thing is having low security hashes or encryption. Anytime, hold on, all right. Anytime you're hashing anything, for passwords, for anything else, I actually had an updated version of this slide that didn't make it into this deck, which was, with PHP 5.5, you have this great new password crypt functions, and I highly recommend you use them because they're extremely secure. The main takeaway here that I want to give you is just never use MD5, ever. MD5 is so easily hackable. How many people in here know the term rainbow table? Oh, good, almost everyone. For the few that don't, a rainbow table is a reverse lookup on a hash. So you can go out there, for example, and find MD5 rainbow tables where you can type in a hash and it returns to you, here's 10 or 12 common phrases that hash to that particular hash. And if it's looking up passwords, for example, given that passwords are typically going to be short things, the shorter things will be in the rainbow table. You put in the hash and it comes back, oh look, one of the options this hash could be is the word password. I bet someone made their password password. You should always salt your hashes. Salting is the idea that if you're going to hash something, you add some phrase to it. So if, for example, if you're doing your own password handling, and again, I highly recommend if you're using the latest PHP, use the built-in new password functions because they take care of all this for you. But if you're doing your own, say for example, someone gives their password to you as password, you end up coming up with some phrase, like the name of your company or just something random, my voice is my passport, for anyone who gets that reference. And you add that to the beginning or to the end or to both sides of everything you do before you hash it. And then you do the same whenever you need to check. So someone going to log in, they type in their password, you re-add that phrase, and you hash it again. The reason you do this is by doing this, you destroy the use of a generic rainbow table. Someone would have to make a custom rainbow table for your site because that extra information is always in there. Someone choosing their password to be password will look different, its hash will look different on your site than on someone else's because their password isn't just password, it's actually my voice is my passport password. But there are so many other hashing algorithms out there that PHP provides, SHA-512, Blowfish, SHA-256. It's very easy to use them. Just do it. For that matter, even SHA-1 is better than MD5, although really use something even better. This same actually applies to your PHP sessions as well. You can actually configure what hash algorithm is used for your PHP sessions. In old versions of PHP, it was MD5. In current versions, it defaults to SHA-1. And you can change that in your PHP to INI. And you can actually now specify that you want your sessions, for example, to be SHA-512 if you want. For sessions, that might be a little bit of overkill because of overhead. But make sure you're, again, not using MD5. Again, I had an example, but let's move on at the moment. So let's talk about various real attack vectors now. Okay, people are coming in, are attempting to hack you in some way, shape, or form, and you need to protect against them. So the first I want to talk about is SQL injection. All right. SQL injection is one of the most well-known. Most people understand, hopefully. And it's simply the idea that a user has the ability to send you data that's going to be directly interpreted by your SQL engine. So the security hole in this case is simply having a string, a query that you are making where you are using direct post or get variables, anything that came from the user. All right? Now, all it takes for someone to attack is to enter as their name, quote, or 1 = 1 semicolon. Now, this phrase that was selecting star from users where name equals and password equals becomes select star from users where name equals blank or 1 = 1, and it just selected the entire table instead of the one specific user you wanted. If this was being used to log in, they now just logged in as user number 0, which quite often is your admin or root user. They could also have entered where name equals and enter a username they wanted, or 1 and then semicolon, and so you've now just logged in as that user without even entering the password. All right? The solution to this, there are two solutions. The main solution is to use prepared statements. If you're using PDO as your database library, this is an example. Other database libraries give you other ways to do it as well. But the idea is that you prepare a statement with placeholders for where those variables will go. So we now have where name equals question mark and password equals question mark. And then you execute it passing in an array of those variables. By doing it this way, your database understands that the data coming in, for example, in this question mark, where name equals question mark, that is only to be treated as a string to match against name. It can never contain other SQL statements in it. If someone does try to enter, quote, or 1 = 1, it's only going to look for an actual username called quote or 1 = 1. The quote is not going to end your quote. Someone's not going to be able to directly inject SQL to you. The other option is to use some type of escaping or quoting. If you're using the old MySQL library, which you shouldn't be, the function is MySQL real escape string. You shouldn't be using that one because it's already deprecated and about ready to get removed from the language. If you're using PDO, it's PDO quote. This also protects you. It protects you by going ahead and making sure that any quotes that are in there are escaped out so that the database will not interpret them as exiting and continuing on. It'll make sure things like semicolons are escaped out. You should not. You will see lots of old code that protects themselves by doing add slashes. You should not. The problem with add slashes, or even manually going in and finding any quote and putting a slash in front of it to escape it out, is that only escapes normal standard ASCII slashes. Databases are very smart nowadays, smarter than they should be in some cases, because they understand multiple language sets and multiple character sets. There are lots of characters that might get interpreted as an open and end quote throughout the UTF-8 or UTF-16 namespace, not just the low ASCII single slash or single quote. Using PDO quote will properly escape everything that needs escaped in that string no matter what. Although I really highly recommend you use the prepared statements when you can. The only case you can't use prepared statements, and that I go, it's okay to kind of do the quoting version, is if you're trying to use, you're trying to do something, which is kind of a scary thing anyway, but where you're not just looking at a comparison to a column, like where name equals question mark and pass equals question mark. If you're, for example, building part of your query on the fly and like the name of the table is stored in a variable, you can't do a prepared statement with a question mark where the name of the table is. So in that case, you do need to use quote to quote the name of the table. Or just don't ever trust data from a user to be the name of a table. So as Chris gives a thumbs up back there. I've seen a few use cases where I can kind of give it a skip, but really, just, yeah, don't. There are other types of injection besides SQL injection. These are less common, but just as important for you to think about. One is command injection. If you actually in your PHP code at any point are running a command line, okay, if you're calling system or if you're using the backtick notation, the one case this is very common in PHP is if you've had someone upload images, for example, and you're going to like use a system level tool to resize the images into multiple sizes, make a thumbnail of it and all that. And so you're actually making a command line call in the midst of your PHP. It is possible for someone to inject code into that command line and do bad things on your server. So you need to make sure that anything that came from the user is properly escaped. There is a function that escapes things properly for the command line, and I am blanking on its name right now. And Chris is blanking also in the back. So shell arg escape. Anyway, if you look for it, there is a specific command that allows you to escape user input to make it safe to put on the command line. Escape shell arg. There we go. It's so rare that I use it because it's very rare I'm doing it anyway. Speaking of file uploads, having unchecked file uploads is another issue. If you are having a place on your website where people can actually upload files, maybe you're letting them upload again, like headshots for their profile, or they're uploading PDFs, you need to make sure that what's being uploaded is what you thought was being uploaded, okay? If you're expecting them to upload images, make sure they actually uploaded an image. They might have tried to upload an executable file. Now, them uploading an executable file in and of itself is not a direct problem because you're only going to ever treat that as an image, perhaps. But once they're able to do that, multiple attacks, if they're able to upload an executable file and then manage to do command injection and now run that executable, so many of these attacks play together. One moves to another to another. So really, there's two parts to make when you're doing file uploads. One is make sure you are using all of the appropriate functions that PHP provides. If you go to the PHP page on php.net about how to do file uploads, there is this specific sequence of functions that it has where you call this, like you don't copy the file itself to where you want it to be. PHP has a function of move uploaded file to move that uploaded file. That actually does a lot of sanity checks for you to make sure that the user, for example, didn't fake the file name that they uploaded to look like /etc/password, so that you end up moving etc password into your graphics directory, and then they can access that directly and get access to it. PHP protects you from that if you use the PHP functions. Again, the flip side of that is check the file types. And you can't even just trust the extensions. The extensions, of course, help to stop if someone does something kind of slightly bad. But if you want to truly be secure, if you're expecting someone to upload a graphic file for you, truly make sure it's a graphic file. There is the get image size and get image info. There's a number of functions built into PHP that allow you to inspect a file and get back its image information. If that comes back saying null, it wasn't an image. Same things can happen. You can just check the MIME type of what comes through as well. Yes?
Is one of those functions to check a file off the vulnerability itself? You might upload something that, knowing that upon being checked, it was actually
That is a good question. As far as I know, that shouldn't be a problem because those functions like the getImageInfo, I know that there have been some things like that in the past, but that those things are kept up to date on security to make sure that that should not happen. At some point with a lot of the security, you do the best you can and be as secure as you can, and there's always going to be new exploits. If there is a new exploit, you need to be on top of it and make sure you get your software updated as soon as you can. The last injection I want to mention is code injection, which is simply the user being able to inject PHP code that gets interpreted as PHP. The moral of this story is never use eval, ever. If you've ever thought about using eval, stop. Erase that thought from your mind. Don't use eval. Okay, moving on. So if you're not using eval, they can't inject PHP code. All right, so let's talk a bit about session hijacking. Session hijacking is actually a fairly serious problem, and it's not one that you can 100% stop. You simply have to make it so hard for someone to do it that it becomes not worth their time to even attempt to do it. Okay? The idea with session hijacking is one user becoming another via impersonating them. All right? If you think of PHP sessions, with PHP sessions you simply have a hash key, and anyone who passes in that hash gets that session. So if you happen to get hash 1234, and you're now a logged in user and running around with session 1234, if someone else connects to the server and goes, "Hi, I'm session 1234," they are now you by default. All right? That's one reason not to use MD5s for your session hashes, but to use something more cryptographically dense. Again, SHA-1 at the least, something more complicated if you want, so it makes it that much harder for someone to even guess what someone's session key would be. But there's a number of other steps you can take. One thing you want to do is to avoid session fixation. This basically translates down to do not use URL cookies, and hopefully no one is. URL cookies were something that started back in the early day of PHP. It can still be turned on, but you should turn it off, which is where the session is not done by a cookie, but it's done in the URL. You'll see the question mark PHP session ID equals. The problem with that is that if your PHP script allows that session to come through in the URL, that means I can put a link on my website to your website with a session ID in it. Anyone who clicks through my website to yours has that session ID that I know of. So I can now easily connect to the site, put in that session ID, and become whoever just clicked through. All right? If you're using cookie-based sessions, then you're protected against that. Another is to always regenerate session IDs on a change of access level. So if someone logs in, regenerate their session ID. When they log out, regenerate their session ID. If they were already logged in and now re-authenticate as an admin versus a regular user, regenerate their session ID. The idea is that at that point, if someone somehow had figured out who someone is, as a non-logged in user, they log in, they now have a new session ID, there's no way for someone else to have known that. And the other is to save an anti-hijack token, and I'll go into some more detail on that in a minute. But the idea is that you try to pass some extra information back and forth with the session that is unique to that specific user. So that if I come in and say, "Hi there, I'm session number 1234, you can validate a few things and go, "No, you're not," and try to kick them out. But let me go into some more detail here on some of this. So first of all, again, I mentioned session fixation. This all comes down to being allowed to have the session ID in the URL. The way to fix this is there are two configurations. One is session use cookies equals 1. The other, which is the one a lot of websites don't have turned on and should, is session.use only cookies equals 1. If you have use cookies 1 but not this other one, your website by default will be using cookies. But if someone types a URL like this in, it will interpret that as a session. And so you are still vulnerable. So both of those need set to 1. I also talked about regenerating access levels. This is just an example of this. So you want to, again, if someone logs in, regenerate their session ID. The call was session regenerated ID, and true, I'll tell you about true in a second, and then same thing. If they logged out, regenerate their session ID. True, in my opinion, is a very important parameter, and I have no idea why it's not the default. But, well, I know why it's not the default. It wasn't in the beginning, and backwards compatibility, because PHP is big on that. If you do not pass true, session regenerate ID creates a new session, but leaves the old one hanging around. So someone who could still, who had access to the old session ID, all that old session information is still in there. If you pass true to regenerate ID, it regenerates the new one, copies all the data over, and then completely destroys the old session. So it's a much safer thing. And there's really no reason that you would ever want to have the old session hanging around. I cannot imagine a single use case for that. So again, I talked about the session anti-hijack measures. What you want to do is store anything unique to that user's session that you can, so that you can try to reinterpret that back, all right? This is not a few lines of code solution. I have it on the I have a smallest possible version on the next slide I'll show you. But again, you want to store whatever you can. There are some things you can check and some you can't. For example, one of the main things you check is the user agent. Because theoretically, the user agent should not change between two requests. Should not. I see you back there, Chris. It should not change. I.e., if I'm browsing using the site on Firefox, and then all of a sudden a request comes in to, hi, I'm actually session 1234, and the person's using IE, that's not the same person. Because sessions are cookie-based, the cookies are browser-specific. Even one user browsing on multiple browsers on their local machine, each browser will have its own session ID. Okay? I said the user agent shouldn't change. If you use Firebug, this will bite you in the butt all the time, because Firebug actually will change the user agent when you turn Firebug on or Firebug off to announce that it exists. And so you'll be using a website and then turn Firebug on and suddenly you're logged out. And you're wondering why. And usually it's because a session anti-hijack made it look like you were trying to hijack the session, because now there's a different user agent when it really wasn't. But there's a lot. The problem is there's not much you can really use. For example, you would think you could use IP address, because, hey, this new request came in, but it's from a completely different IP address. Unfortunately, that may have been true 15 years ago. But now, because everyone's sitting at home on their cable modem or whatever and getting dynamic IP addresses, at any moment your IP address may change. If you're coming in from behind a corporate firewall, every single request may be coming out through like one of 3 IP addresses randomly chosen. So you can't trust that. And most other headers end up changing on the fly also. You used to be able to use the accept header, but now browsers modify that on the fly based upon the type of content being requested. So if the browser knows it's requesting an image, it only says it'll accept images. If it's making a general request, it only says it'll accept HTML. And so you can't trust that one either. So I don't know if you can actually read all of this, but again, the slides are on my website, so you can get this in more detail. But this is sort of my compress it into one slide version of doing this. And so I'll just real quickly run through it here. So what I have done is I've made, and this is in the midst of a greater user class that I usually have, is I have a function here for session start that actually starts the session, but then it goes through and does a few things. So first, what I actually want to focus on first is down here at the bottom, which is where I generate my actual hijack token. All right, because I use that multiple times for checking. So the first thing I'm going to do is actually look at their user agent. And just in case it's empty, I'm going to default it to like NA or something like that. Otherwise, I'm going to use the user agent. I'm going to add in some type of salt, because again, I'm going to end up hashing this. And if you're going to hash anything, you want some kind of salt in there. So I'm adding in a phrase. And then I'm adding in one other thing, which is a timestamp of when this session started. All right? And you'll see how this comes into play. So basically what this becomes is something random yet unique to this session, okay, that you can now check against and that someone trying to hijack would have to somehow figure out. Because the problem is, if all you're putting into your hijack token is the user agent and like a salt. Well, every single time you connect with Firefox 3.6, you'll get the exact same hash back because it's the exact same thing being connected. So now people can understand what that hash is and guess the hash. Oh, well, let me try the hash that I found by using Safari. Let me try the hash I found using Firefox. By putting this timestamp in there, it means every time someone starts a new session, they're going to get a completely different hash back each time. So then, when we start the session, if the session is not empty, we're going to do a bunch of checks, all right? So if the session was empty, let me go to that first. So if the session was empty, which means it's a brand new session, because otherwise there would be stuff we'd stored in there, we're going to store, again, this timestamp on the date started. We're then going to generate the hijack token and store it in the session. And then we're going to send that hijack token back as a cookie to the user. And you can name that cookie whatever you want. I recommend not naming it anti-hijack token, because again, you're giving people information. Not that it really matters, but name it something cute. Name it data to just be boring. Do whatever you want. So then if they come in and the session was not empty, you're going to regenerate the hijack token based off of this information. You're then going to say, was there a hijack token in the session? If so, copy it as, was there a hijack token in the cookie? If so, copy it. And then have this lovely little line of code here which says, if there was not a hijack cookie in the session, or there was not a hijack cookie, a hijack token in the session, if there was not a hijack cookie sent in, or if they do not equal each other, or if they do not equal this new token we just generated, then something fishy is up. All right? Because all three of those have to match. They all have to exist, and they all must be identical. So if that didn't happen, what we're going to do is just close the session, generate a new session ID on the fly, start a new session, delete the hijack cookie, and redirect them back to our home page. To basically go, okay, look, it looks like you were hijacking, so we're just going to destroy this, what you just tried to do, and we're going to send you back to the home page and bounce you away from here. All right? And you'll notice we're not destroying the specific session that they were in, because that's someone else's session. We still want to exist. We're simply closing out that session, then giving this user a new session ID and bouncing them back. Okay? Yes? And by the way, that shouldn't be an MD5. The problem is, if you do session write close, then just session start, it still keeps the same session ID. Because the inside of PHP, it knows, oh, my current session ID was 1234. So unless you explicitly send a session ID back at that person, they will just send back to you 1234 again. They will constantly try to keep hijacking it. So you have to forcibly give them a new ID to tell their browser to blow it away. Theoretically, you could use regenerate ID with FOSS, and it wouldn't mess up the old session. But that just feels okay to me. It feels dangerous, even though I guess that would be a valid use case of it. All right, I can move on time. So, XSS or cross-site scripting. This is one of the biggest attacks that will happen all the time. And this is simply the user's, all of this comes down to don't trust anything the user gives you. This is the user sending you data that gets executed as a script. All right? There's many ways this can come in. In all cases, trust nothing the user gives you. So this is if they're submitting a form. Do not trust the headers their browser sends you, because they can modify those. Do not trust their user agent. They can modify that. I have seen lots of attacks come in via someone modifying their user agent in Chrome to be an attack string, and as they're just randomly browsing the web, they're constantly trying to hack the web. The idea to fix this is that you're going to do FIEO, filter input, escape output. You always want to filter anything that comes in for what you were expecting. If you're expecting an integer, make sure you only receive an integer. And then you always, when you're going to put any output that the user gave you, you always want to escape that output so that even if somehow a script came in, it will not go out and be interpreted as the browser's script. By filtering in and escaping out, you are always protected. Theoretically, if you always filter in or always escape out, you'd be okay, but you want to do both to make sure you are doubly protected because you're always going to forget something somewhere. It happens. Something else I also had here is don't forget about rewritten URL strings. Most frameworks now, we're not doing the old Apache routing where the URL actually means it's looking through the file system for a file. Most URLs now are read into your framework, and then it's parsed by your framework and turned into routes and controllers and all that, which means you can't trust the URL string either, because the user can put attacks into the URL itself. So there's 3 types of XSS attacks, and I want to walk through them real quick. The first of all is reflected XSS. This is simply directly echoing stuff back to the user, all right? So the security hole is simply saying, thank you for your submission, post first name. And then the attack is someone simply putting in something like this, putting in a script tag. You'll see alert XSS used often in examples because it's just an easy way to find out, was this interpreted as script? Because I was able to put script alert XSS, I submit it, and suddenly I get an alert pop up. That means I was able to inject script under the page. A lot of times people look at this and wonder, is this really a problem? Because the user can only attack themselves in this particular case, right? The user had to enter this to make it be echoed back to that user. The problem is, and I had a slide, again, I forgot to put it in this deck right now, of this wonderful part of Facebook. It was hilarious. Because users are dumb, and they can be talked into anything. How many times have you seen, like for example on Facebook, someone post a, hey everyone, type this or paste this into a comment form and hover over this image and then see what happens. And people will do it. And like one of the best ones I saw, and I had a screenshot of it, was someone on Facebook doing a, hey everyone, there's this great feature on Facebook. You can type your password into a comment field and it comes through as all stars on the other end. Look. And then 2 or 3 people who were in on it will just make posts that are all stars and then go, oh, wow, it worked. And then the 4th person types their password in. And the best one, the screenshot that I found, like the person's password was, I secretly love 50 Cent. And the next comment was, you bastards. So people can be talked into anything. It's so easy for someone to go, hey, everyone, try this, and to talk someone into doing it. Okay? The solution to this, again, you always have to escape any output for the specific way you're using it. So if you are escaping for HTML, you use either HTML entities or HTML special chars. HTML special chars only encodes the bits it has to for protection. HTML entities is a more thorough encoder. You can use either. I like entities because it's shorter to type. But really, they end up doing the same effect for you. And you pass in the post. There's some options you can pass in about whether you want, how you want quotes handled. Do you want double quotes escaped? Do you want single quotes escaped? Do you want them all escaped? Int quotes does them all. You do need to make sure you pass in your character set because it escapes appropriate to character set. If you do not pass in the character set that your HTML is expecting and that your PHP is using, there are exploits people can do by understanding that they're passing in ASCII and it's getting interpreted as UTF-8 or vice versa, and there are ways to get around not having stuff escaped correctly. And this last parameter, which I have false here, if I remember correctly, is whether or not to re-encode, where if it sees something already encoded, does it try to double encode it or not? And so you can configure that. If you're taking this data and you're escaping it out as JavaScript, if you're echoing it out as some sort of your live generating JavaScript, there's this funky code here that seems to work well. I found this a long time ago, cut and pasted, and it works. And if you're escaping as XML, you cannot use HTML entities or HTML special chars because a lot of the HTML special characters are not valid for XML, and your XML will yell at you. Again, this is just a magic incantation that works well for XML. Cut and paste it, enjoy it. It just does this funky thing of escaping all the low ASCII stuff by converting from UTF-8 to UTF-8 ignore. And it's weird, but it works. So the next type of attack is a stored XSS. So now you're not reflecting stuff directly back to the user. You're storing their input in the database, for example, and then later echoing it back out. So the security hole here, again, is you're taking input from the user and storing it directly in the database. Now, we're doing the right thing here to protect against a SQL injection. We're using a prepared statement. But that doesn't protect you against the XSS. Because if someone actually, again, puts in a script alert XSS, that gets stored as their username. This is a more serious attack now because now it's not the user hacking themselves having to get tricked into it. Now, I can go on the website, change my username to have a script tag in it, and anyone who comes to my page on my profile runs that script. And now if you're sitting there thinking, well, what does it matter that someone can inject some JavaScript onto the page? Realize once you can run random JavaScript, you can do a lot. For example, you can grab their session cookie. You can grab all their cookies and then have it post off via Ajax to another website where you're recording them all. There may be other things on the page. If, for example, they're browsing around, they go to their page where they're logged in, maybe you can now read private data off the page by using the document object model and reading through the page, retrieving information that was otherwise private to them, and again, send it off via an Ajax request to another website. And these attacks, even though you think about this script alert XSS, it's a small little thing, who's going to type some ridiculously long thing into there? You don't have to, because you can simply put a script tag in that loads a script from another website. And now, injected onto these people's pages is a script tag loading a script from another website, and the attacker can continually update and modify the script on that other website. It can be a gigantic JavaScript file, doing anything and everything at once and constantly updated, and it's always being attacked. So the solution to this is exactly the same, all right? Besides doing your best to filter that what you expected was what you got, how you escape this is the same, all right? Whether you're taking data that came in directly from the post and echoing it out, or whether you're reading it from a database and echoing it out, you want to escape it for the specific purpose that it's about to be used, all right? Now, the third type of cross-site scripting is the far more complicated version, and this is DOM XSS. DOM XSS never touches your PHP, so you cannot protect from it in PHP. This is where you were doing a lot of Ajax or other modern JavaScript stuff. Someone is entering data on a form, and you're using that data instantly to modify what's happening on that page. So they're going in and typing in, like they're updating their information, and instantly it's being reflected. Maybe on the back end, you're still sending that via Ajax request in the background to save it, but you're actually updating stuff based upon what they typed. So again, like in this case, we have a case where we're adding a submit handler onto a form, and whenever they submit it, we're going to look for the input with name first, and then append at the bottom of the body, thanks for the submission, first name. Now someone can put any type of script in there, and that's going to get interpreted by your browser and run, but your PHP never sees it. There is one solution to this, which is don't ever do this. You could always choose to send the data back to PHP and have PHP send data back to make sure that it's filtered and that it's escaped. But often that's subpar. That's not what we're trying to do in modern Web 2.0, 3.0, whatever, websites. So this is a simple solution. The problem with this is that JavaScript does not have any built-in escaping functions. It was just never designed with that need in mind, so one was never made. And they've still never made one. There's actually some that are being proposed for future versions of JavaScript, but you can't rely on them anyway at this point. So here's like a very simple solution, which is basically replicating what HTML special chars does, where you're just looping through the string and looking for less thans, greater thans, and quotes, and replacing them, and then echoing that back out. However, I don't recommend you use this, because the problem is, typically when you're doing JavaScript work, you're not just echoing out HTML. You're often creating CSS on the fly. You're modifying, you're putting class names in. You're modifying IDs. You're putting other parameters in. You're generating tags on the fly. There's all of this that you're doing, and you can't just apply this to it, because if you're trying to generate a tag on the fly, you don't want to escape out the less than and greater than. That defeats the purpose. But you need to escape other things. And how something needs escape to be part of a parameter, like a class name, is different than how you would escape here. So there is this really great library I will point you to. It's on github.com. Chris's Beef is the name of the guy's account. And it's called jQuery Encoder. It's this great library that specifically has kind of everything that you need to, has separate functions, excuse me. It has separate functions for how you need to escape for HTML, how you need to escape for an attribute. Sorry, let me flip back. I saw someone was getting ready to take a picture. There we go. But it makes it very easy. You just instantiate the encoder and then say, I want this encoded for CSS. I want this encoded for, you know, a body tag, whatever. All right. I am running low on time, so let me try to push through here. All right. The next biggest attack here that you will see often are cross-site request forgeries. A cross-site request forgery is now taking that next level. It's the user forging a request on behalf of another user, okay? So you're essentially making the other user do something kind of thing. You're making their browser do something, all right? So let me get to the example here. So the simplest version of this is someone putting an image tag, for example, on their website. So you come browse my website that's an evil website trying to do bad things to you. And I have this height 1, width 1 image tag that's actually a URL to your website and sending a bunch of GET parameters. So when you browse my website, I force your browser to make a request to this other website, passing in whatever parameters that I wanted. I have now forced you to make a request you didn't even know you made. All right? For example, and this is something that you can still do to this day as far as when I last checked, it's possible to do this to force someone to add a book to their Amazon queue. So there's a way you can make a URL on Amazon that if you come and like visit my page, I'm an author, I have written a book, it's for sale on Amazon. You then happen to go to Amazon and look at your cart and my book's magically in your cart. I can't, Amazon like that. You can't make them check out, right? So I can't make you actually buy it, but I can put it in your cart, and if you're not paying attention when you go to check out the next time, since Amazon saves carts forever, that's why Amazon has not fixed that hole, but because it's kind of a half attack. But that's the simple version. Of course, if you're not using get data, this won't work, right? If someone needs to actually send post data to do the attack, like to try to log someone in, but you can do that via using JavaScript. Via JavaScript, you can cause a post to happen on behalf of the other browser. It can happen via Ajax. If for some reason the Ajax request is blocked, it can happen via simply opening up an iframe, and in that iframe having JavaScript that creates a form and then directly submits that form via JavaScript as a regular post. No Ajax happened, but it's happening in a hidden iframe and you never saw it happen. All right? So what you have to do to fix this is you have to somehow make sure that the actual user really made that request, that their browser wasn't tricked into making it on their behalf, right? So the way you do this are via CSRF tokens. In some frameworks, they call these nonces instead of tokens. I like token because token's easier to say to me than nonce. So what you do, this is kind of like the anti-session hijacking. You're going to generate some unique form, some unique term, a hash, that only that user could know. All right? And the way you make sure that only that user actually doing the request would know is whenever you're going to generate your form, all right, you create this token. And you're going to put this token into the session, and you're going to put the token as a hidden field on the form. When this form is now submitted, you are going to check and make sure, was there a token sent in with the form? Does the token match the token in the session? If I'm going to write code on my website to force your browser into posting on my behalf, I have no idea what that token is going to be. The only way I would know that token is to be in your browser, right? And that token will change every time potentially. You go to the site, you load the form, a brand new token is generated for you, all right? And you can add a little extra security, which this example has, by making the tokens expire, have them only last for so long. So, hey, every token generated is only good for 5 minutes. And that helps in cases of conferences like this. Because if you walk away from your computer for a minute, someone could view source on your page, see what that hidden token field is, write it down, run off, and then later go and try to use that token to forge a request on your behalf. So if you make the tokens expire on a regular basis, then that helps protect that a little. Some websites I see that do this just generate a single token for the whole website because it's easier. Some actually generate a specific token per action, so they make like a login, logout token and adding a comment token. And I've seen others that make a completely separate token for every single form that's generated at every point in time. It's really up to you. In my opinion, 1 token or 1,000,000 tokens, it's about the same. The only thing you're protecting yourself a little bit more about making extra tokens, is if someone does somehow compromise 1 token, they can only do that action on behalf of the user. They can't do all the actions. So it's a little more secure if you add the extras. And then I want to get into the newest type of attack that has come around. It's one of the nastiest, and it's called clickjacking. This got a lot of publicity a few years ago, I forget how many now, when this hit Twitter heavily. And if anyone remembers it, this is back when suddenly Twitter got completely filled with everyone seeming to post, hey everyone, watch this. And there was a link, and you took the link and it took you to a website that had a button you clicked, and then nothing happened. But it turned out that it now posted on your behalf, hey everybody watch this, and it became this viral attack. The deal with clickjacking is that it's taking CSRF to the next level. You're now not forging a request on behalf of the user. You're not tricking their browser into making a request that they didn't. You are actually tricking the user into physically making a click on another website. And this is kind of hard to explain, so I have a sort of mocked up demo here to show you what this can look like. So let's imagine I've made this evil website here, all right? And it says, welcome to my nifty website, why don't you click my button? Maybe that's a huge button that says win free kittens or win an iPad or whatever, right? You somehow entice people that they want to click that button, right? Now let's say there's this other website called Quacker where you post whatever's on your mind at the moment up to 140 characters. And that someone simply can put whatever they want in there, and then if you click this Quack It button, the message goes live. Now what if I took that other website and I put it into an iframe on my website? Okay? Now what if I took that iframe and actually positioned it so that the Quack It button was right on top of where my button was? And now what if I took that iframe and made it opacity 0? That iframe is there, sitting on top of here, but you can't see it. The Quack It button is sitting right on top of my button there, but you can't see it. If you actually go and try to click that button now, you are actually physically clicking the button on the other website in that iframe. You have truly made that request. You loaded the remote page. You got any CSRF tokens that came with it. And you physically made the request. You just, with the thinks of CSS and opacity 0, you had no knowledge that you were doing it. And the best part is of course that my button doesn't get pressed, right? Because the iframe took the hit. So it doesn't look like it worked. So you try again. And this is why Twitter got flooded, is people got to this other website and went, oh, the button didn't work. People said it was a cool thing, and so they'd hit it and kept trying to hit it, and we're just flooding Twitter with it. So there's a couple solutions to this. The main solution is that there is this new header that you can add to your pages to say, do not allow my page to be put in an iframe. All right? It's header X frame options. There are 3 options. One is allow, which you should never use. Deny is the safest, which says my website should never, this page should never ever be loaded into an iframe. And you also have the option of same origin, which if you're using frames or iframes on your own website, that allows your pages to be framed within the context of your own website, but it doesn't allow another website to do it. The one problem with this is this does not work in all browsers. This is a fairly new thing. It actually, in October, became an IETF standard, so all the browsers are implementing it now. Interestingly enough, this got started by Microsoft, of all people. They went, we need a solution to this. And Microsoft and I think Mozilla worked together and came up with this solution. But some browsers like Chrome weren't going to add it unless it was a standard, because that's how Chrome is. But now that it's a standard, it's appearing everywhere. There is one other solution you can do, which is a really nasty solution, but it works, and it will protect your people even if they're using an old browser, which is this really funky CSS and JavaScript trick. Basically, in your head, you set your entire body to display none. You tell your entire website, don't ever display. Then you have a script tag that checks to see if you're in a frame or not. It checks does self equal top. Self would equal top if you're not in a frame. If you're in a frame, self does not equal top. So if you are not in a frame, it then, via JavaScript, goes back and changes the body display to block instead of none. If you are in a frame, it redirects you back out of the frame. This works. The drawback to this is if somebody has JavaScript turned off but CSS on, they will never see your website. Also, if someone has CSS off but JavaScript on, they can still be hacked. Because the only way this works to protect them is by making your website not render when it's in an iframe, so that button never exists. But it's only the CSS protecting that. The other drawback is if someone's on a slow connection, this causes a flicker. Because your page renders with the display none, and then the JavaScript has to run. All right, I'm going to just real quickly run through because I am running out of time. Sorry about that. Brute force attacks, kind of good luck. But your main 2 protections for this are either using a CAPTCHA. Does anyone not know what a CAPTCHA is? Good, okay. Or doing IP rate limiting can help with this. It can help with automatic attacks. Make it so that if 5 login attempts happen within a 2-minute period, that was probably not a user. That was probably a script. And so just block that IP from logging in for a period of time. Again, if you're going to do CAPTCHA, I recommend reCAPTCHA. It's free, it's easy, and you're helping translate books while you're at it, or transcribe books while you're at it. So let me skip past that. And again, there's the only allow so many fails per IP. Again, in this case, it was, 4 attacks in 5 minutes. For true server attacks, as a programmer, number 1 thing is make sure you keep your stack updated. There's no reason not to be running latest Apache, latest PHP, preferably latest MySQL. As attacks come out, patches are made. You keep yourself protected by always make sure you're updated. If you start talking about DDoS and similar attacks, good luck, hire an ops team.
That's beyond the scope of programmer at that point. At that point, you need firewall software. Preferably, you need hardware firewalls that are helping protect you against that. It's not something as a PHP programmer you can really do. And I had real quick man-in-the-middle attacks. Does anyone not know what a man-in-the-middle attack is? Be honest. No? Okay. A couple, okay. Man-in-the-middle is simply where you thought you were connecting to server X. In fact, you were on conference Wi-Fi, which wasn't really conference Wi-Fi. Someone was pretending to be the conference Wi-Fi and is acting as a proxy between you and the server at the end. They are now seeing every single packet of data that's coming across. They know everything that's happening. The solution to this is simply use SSL. That's what SSL was created for, was to make sure that you are only talking to the end server you meant to go to and that no one in the middle would appear. Because if someone in the middle tries to step in, you get an SSL security warning, and you have to explicitly click through, which hopefully you don't do. I have run out of time, so I'm going to skip by these bits here. You can read them on my website. And I'll actually skip by the brief commercial interruption, was just to say we were back in print. And if you haven't seen, we're running a Kickstarter to sell orange elephants. If you like to get an orange elephant, you have 10 days left. And that's it. Please rate me. I love getting feedback of anything you can tell me. And again, I'll be around all week, so all week. Oh, today. There we go.